Hello and welcome to another video. In this one we're going to be talking about merging strategies in Git. There are 3 presented by GitHub, which we'll go over. We're going to talk about merge, squash merge, and fast forward. And merge is my favorite. However, perhaps by the end of this video I will convince you that squash merge is really the only one that you can do at any sufficiently large contributor base in a repository. But I'm going to explain all 3, and then I'm going to show you a cool little trick that I've written to retroactively convert a repo from merge commits into squashes. I'm going to use a version of this technique to clean up a repository I'm working on, and so I will show you its effect and how it was way simpler than I thought it was going to be to actually implement. But anyway, let's jump into it. And for this, I've prepared a paint drawing beforehand to sort of explain the 3 different merge strategies. In this, you can imagine time going from the bottom to the top. We've forked off a branch from a particular point in time, this A commit, and we've put commits D, B, and F on it. Meanwhile, the main line has progressed and added commits C and E. It's not really important what those commits are, but this is kind of the structure that we're going to represent. And so we're going to represent the 3 different scenarios that happen here. The first is our merge. Let's pick a different color and talk about merge. And for that, let's merge is actually, I think, the easiest to represent because we take the original commits, we keep them all completely intact, and we make a new commit on our main line, which is a merge commit. This is just a special extra little commit here. We'll call it M. And this merge commit represents a pointer to both E and F as merging together and progressing the history further. I like merge personally because it keeps the exact history as it happened on the pull request on that branch and preserves it in the future. The downside to this is it keeps the exact history of that branch and preserves it. And so if somebody writes a bunch of garbage commits on their branch, those will get preserved forever in the Git history. And so in order to use the merge strategy, or I would recommend only using a merge strategy on a repository where every contributor actually cares about carefully crafting their commits. Atomic commits is I believe the term that people use, where you only do once in a particular commit. You're not having a bunch of like fix, whip, temp, whatever commits. You're being very careful about rebasing and properly representing the stages of changes in your commits. That's really the only way that merge makes sense. Otherwise, you have all these garbage commits that are going to be in your repository forever. So let's talk next about the other merge strategy that I don't recommend. I actually don't recommend it because it has all the downsides of merge and all of the downsides of squash. And that is, what do they call it? I think they call it fast forward, but really it's actually more like a rebase, at least the way that I think about it. If we take our same set of commits here, we're obviously preserving the main line because otherwise you would just trash your history every time you made a pull request. In a fast forward merge, the commits of your branch are taken and then replayed on top of the main line. Obviously, let's clean up this little. I should have done this more carefully. They're replayed on top of the main line, but they're given new commit IDs. So for instance, this B is not this original commit here. You can kind of think of it as like, I don't know, B prime here. Sure, we'll reuse green as representing these. So they're not the same commits as before because they have a different base, and anytime there's a different parent, you have a different commit. And so this is sort of how a fast forward merge looks like. And again, this has all the same problems of merge in that all of the commits from the branch are still represented in the output, but they are different commits from the original ones. So you can't easily say like, hey, was this F commit merged into my branch? Here you can say, is F merged, because you know it's reachable from this particular point on your branch. Here, it's a new commit ID. It's something completely different from your branch. And so it's not easy to answer that question. And again, you end up with all the same garbage commits as before. And the third strategy, and perhaps by the end of this video, I will convince you that this is the one true way to work in a large, either large company or large code base where you have lots and lots of people, is not merge, but squash. In this particular case, again, you're still preserving that same main line, obviously, in your output here. And in a squash merge, all of the commits of the branch are smashed down into just a single commit, and that is added to your branch here, or your, I guess your primary branch here. So you get a brand new commit here, which brush for commit. You get a new commit here, which is your squashed. So this is, say, like PR123. As a single commit. So all of the commits that were on your pull request branch are gone. They're converted into a single commit and put here. This means a couple of things, which has some nice properties. The first is your history is clean, so you don't have all these, like, you know, if you have people that are just like git push dash or git commit dash m fix, you know, useless commit messages, they're sort of eliminated. You're going to get just the PR information at the end of the day. This also means if you introduced a file here and then deleted it here, that's not going to show up in your history. So if you accidentally added something, noticed it, oh no, I added the file, I'll just delete it. In this particular case, that file is still there because it's still in the history, but when you squash, it's eliminated. And so that's kind of the benefit here. And our three strategies. I've actually covered this in another video, I believe. Merge. It was probably this video. I don't remember. One of these videos I've talked about merge strategies, but here they are again because it's useful for this the story I'm telling here, just so you can visualize the three here. Now, I wanted to show off some of the examples of where this can go poorly, as well as how I'm going to go about fixing this particular problem in a repository. Well, I'm going to fix it in a repository that doesn't matter, and I'm not actually going to do that transformation there because it's mostly my commits that I keep tidy, but nonetheless. I have a copy of the repo that I'm going to clean up, which is the Joseki repo. This repo has a lot of commits in it, and most of the history of this repository was not using squash merge as its strategy, and so there's a lot of, and most of the contributors to it were not, you know, caring about the quality of their commits, and so there's a lot of commits in this repo. And in fact, I think there's actually more if you expand this out. Yeah, because there's some like weird history shenanigans here, but there's a lot of commits in this history, and I don't know, let's do some little, let's do a little shell magic here. %h %s grep -e. We're going to find all the commits that have really short commit messages because almost always those are completely useless. And so we can see, I don't know, I don't know, if it's less than 7 characters, it's probably not a very useful commit message. Oh, did I do that wrong? Git log grep -e. Oh, this needs a plus. Yes. Yeah, so we have all of these, you know, tweak fixes, just a dash as a commit message. This repo has you know, hundreds of these relatively useless commits. Like if you're running git blame and you get a commit message that just says hotfix, you have no idea what happened there. And unfortunately, that makes the repo harder to reason about, harder to traverse the history, and harder to, you know, figure out why something is in a particular way. But I'm going to show you a cool technique where we're actually going to eliminate almost all of these garbage commits by converting every merge in this repo into a squash merge instead. And for that, we're going to be using a really cool tool. I've been using this a lot in exploring ways to fix the history of this repository, and that is a tool called Git filter-repo. It's actually recommended by the Git docs itself, Git filter-repo. It's a Python project, but it's also pretty cool. It's also one file, so it's also really easy to figure out how it works and play around with it. Although it's 2-space indented, so it's, I don't know. From looking at Python, it's a little awkward to work with, but you can always re-indent it however you want. Anyway, we're going to install that tool. Pip install git filter repo, and the idea for this actually came. It was a shower thought. I'll just put it out there. It was a shower thought. The idea for how to convert merge commits into squash commits is actually way simpler than I thought it was going to be. I'm going to use this example repository that has both GitHub pull request merge commits and normal merge commits, just because it helps me demonstrate this problem. If we git log one line graph, you'll see here that I use merge commits. So this is sort of the structure that you'll see in a merge commit. And almost all of my pull requests are exactly one commit. Occasionally there's some with more. Yeah, like in this one, there was an automated commit done by a bot to update my configuration, and then I did a manual commit on top of it to fix it. I wanted these two things represented separately, so I kept them as separate commits. For instance, I guess there were 2 pull requests active at once, so the history looks a little, I mean, this graph doesn't represent it nicely because it's in order in time. But anyway, we're going to use this repo as an example, and we're going to use git filter repo in order to rewrite it. Now, I actually need to copy a command because the command is a little bit more complicated than I'm just going to type out on stream. But I guess before we do that, I wanted to show you the idea that I had and why I thought this would be pretty easy to do. We're actually going to show some git internals here before we do all of this. This is not a merge commit. This is just a normal tag commit, so it's not actually going to be that useful. But I wanted to show you one part of this, just a normal commit that doesn't have a merge, and how we're going to convert a merge commit into a normal commit. And in order to do that, we're going to use git cat file. This is a low-level tool to show the objects that are in a Git repo, and we're going to look at this commit here. You can see this commit has a single parent. This tells it which commit it was based off of, and it has a tree. This is the contents of the repository at this particular commit. This refers to all of the directories and files, etc. It's basically a snapshot in time when this commit was created. If we show the commit that is its parent, this I believe is a merge commit. If it's not, well, we'll have to find another one. We look at this. It's very similar to this. It has a signature, so we're going to ignore that. Commit message down at the bottom. Signature. Ooh, don't shrink the window. We don't need to do that. It also has a tree. In this case, it has 2 parents. That's what makes it a merge commit. It has multiple parents being merged into one. And it has, the same metadata as before, author, committer, etc. And so my shower thought was, the only difference between a normal commit, this one up here, and a merge commit down here, is that this one has 2 parents. So what if we just delete one of the parents? And it turns out that's all you really need to do to convert a merge commit into a squash commit, because the snapshot of that particular commit is represented in this tree. And we basically just, drop this parent, drop it off at the nursing home and just let it no longer exist. That's a terrible analogy. Let's pretend I didn't do that. But basically all you need to do is just remove the merged branch parent and leave the mainline parent in place, and you've suddenly converted a merge commit into a non-merge commit. And it leaves behind all of the potentially nonsense history along with it. Now, git filter repo actually gives us a way to do this. Git filter repo help. The help is really long, but there's a callback functionality, which you write Python code for. Not this. Where's the commit callback? Commit callback. Yeah, so this is a callback for processing a commit object. This is an internal object for this particular tool, but it allows you to manipulate a commit. And our particular little shell script that we're going to write here, which we'll just do right here. Oh, we have the editor in the the ugliest theme ever. That was kind of an accident that we made on stream. Anyway. We're going to do a particular commit callback, which is going to be called every single commit. It's going to have this commit object in it. And we're going to be looking for merge commits. Particularly, we're looking for merge commits that look like ones that were made by GitHub. They start with this text here, and we're going to basically manipulate them. If we get a commit that looks like that, or if we don't get a commit that looks like that, we're just going to leave the commit alone, allow this git filter repo mechanism to rewrite the history and just ignore normal stuff. But otherwise, we're going to find something that has 2 parents, and we're just going to delete one of them. And so if we run this thing here, t.sh, I don't have a fresh clone because I made a virtual infinite. Oh, because I put a shell script in it. Okay. All right. Oh, now we should be able to run that shell script. And it went through, rewrote the history, rewrote 1,271 commits like that, which is pretty cool. And if we look at our history now, Same with the one line, graph, decorate. Oh, also this tool handles rewriting tags, branches, everything. It just sort of does what you would want it to do automatically. And so you can see here, we no longer have that, merge graph looking thing. And instead we just have a bunch of mainline commits because it squashed them all, which I just think is really, really cool. And it was, pretty simple to do. Now there are still merges in this repo because I specifically was trying to find ones where I was preserving this reference to the original pull request number. Git log, I believe it's merges. Yeah. Let's just do one line. There are still 3 merge commits in this repo, so it doesn't, I intentionally made it not rewrite these other ones. These were merges that were done manually on mainline. I believe these two, it's if we look at the dates on these, they were done on the same day. I'm pretty sure GitHub was down this day and I was probably streaming and just let's merge these and move on with our lives. This one, I think I just merged straight to mainline because it was a simple auto fixer. But anyway, you can still preserve some commits if you wanted to, and obviously you could craft your callback in whatever way that you wanted that does more complicated things here. There's going to be a bunch more videos on this particular tool, but I did want to show off this one example where I thought of a simple idea and it turns out just deleting one of the parents converts the commit over, which is really cool. I did want to show you what this script does on that other repo as well, because I think that's interesting. GitHub, Giuseppe Labs, Giuseppe reference, dissociate, just getting a new clone using this reference dissociate trick so that it doesn't have to download the entire repo, because it turns out that this repo is pretty big. DUHS, this repo is pretty big, half a gigabyte. If we run that same script here, it's going to convert every actually the script is sort of broken here, but we'll adjust the script slightly. How do we do that? Yeah, so this repo has squash merges, so they also look like this. So we'll just do and len commit.parents equals 2, and we'll just switch these around. Yeah, that should work. If we run that same thing here, it's going to squash down all of the merge commits in the history, and it actually goes a long way in deleting a lot of the garbage of this history, which is nice as well. And we saw 466 megs before, and it's down to a much more manageable 170 megs. It's still much larger than I would like it to be, and so I'm going to be doing some other stuff. And actually, this has another problem in that half of the history of this repo was merged in one pull request, and so I actually need to exclude that one and do some other fancy stuff. But anyway, I just want to show you that just by deleting by squashing every merge, you can potentially get rid of a bunch of junk in your repo. I bet if what was the command from before? %h, %s. Yeah, how many commit messages are 1 to 7 characters now? Only 80 of them. So I, got rid of a bunch of garbage at the same time, which is cool. Whereas it was, 600 some odd before. But anyway, wanted to show this off. Wanted to show off this easy intuition between what a merge commit is and what a merge commit isn't. Show off these various strategies for how GitHub allows you to merge a pull request, and explain why I like merge, even though in a repository where you can't teach everyone Git properly, you kind of have to use squash. You're going to end up with a bunch of garbage. Anyway, hopefully you found this interesting. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.